Hi,
Okay, hi. So you're Kush.
my name is Saivi. Kush is my first name, but everyone calls me Saivi.
Okay. Nice. So how are you?
I'm good. What about you?
Okay, I'm fine too. Okay, let
Um,
me introduce myself. Yes.
can I turn off my video for the rest of the class? Because I feel awkward with my video on.
No problem. Turn it on. You'll feel friendly. Okay, I want to interact with you also. Okay. Okay, so let me introduce myself first. I am Shruti Bhattacharya and I am a physics teacher, as you know. So I'm from India. So I would like to introduce yourself also.
Um, I'm Saivi. I'm from
Okay, so
India.
your name is Taivi.
Yeah,
Okay, good. And what is your favorite subject?
drama.
Drama. Okay, nice. So you're good in drama, right?
Yeah.
Very good. So let's do a physics today, bit of physics today then.
Okay.
Okay, I'll share my screen, okay? Just give me one moment.
Yeah.
I would like, for today at least, please, can you switch on your video? I would like to see you also.
Sure. I feel
Okay,
awkward.
no problem. Okay, just give me one moment. Okay, so I will share a PowerPoint. I hope you're able to see the screen share.
Yeah.
Okay, so you are going to be in class 9, right?
Yeah.
Okay, so today we will do a very basic topic, which without which you can say that you cannot know physics. For physics, this is the most important thing. Okay, so that is units and measurements. So this is the first chapter of your grade 9 IGC's curriculum. Okay. So let me start with like this, that suppose if I ask you that how far is your school from your house, how would you say? That you'll say very far or very near?
Very far.
Very far. Okay, so will that be a perfect definition? Or like if you say that suppose it is 15 kilometers from my house, that will be a better definition,
Yeah.
right? So for that, we need to measure certain things. Then only you will be able to say what is the distance. You'll be able to say what is the, say any mass or any time. Suppose if I ask you that I will meet with you after 1 hour. So that means you have to count that time. So this units and measurements are a very important thing in physics. Okay. So let's start with first numbers and units. Uh, physics is basically everything in physics is a physical quantity. So what is a physical quantity? Anything which can be measured. So can you give me one example?
Um, like liters of water in a jug.
Okay, very good. And like now, just now I told you that distance from your school to your house, say it's 15 kilometers. So can I say that the distance is also a physical quantity? It can be measured, right? Okay. For example, the distance of 10 meters. Okay. So here, whenever we talk about a physical quantity, it is like 10 and meters. That means it has to have a number and a unit. Okay. So here the number is 10 and the unit is meter. So, or in other words, you can say 10 times 1 meter. So 1 meter length is a certain length. If you do 10 times of that, it becomes 10 meters, right?
Yeah.
Yeah. So let's suppose another unit, let's take. So can you see the picture?
Yeah.
You see that a girl is cycling and suppose the time is given here Yes, the time is mentioned. It has started from 0 seconds and it has completed at 2 seconds. And the distance covered here is 10 meters. So that means what? That 10 meters she is covering in 2 seconds. So what else information can I get from there? Let's see. So we can know what is her speed, right? So I hope you have heard about the term speed or studied it before, right? So
Yeah.
for the term speed, we need to know the distance and the time taken. So here you notice one thing, it is 10 meters by 2 seconds and we get the information that her speed is 5 meter per second. So here also 5 is the number and meter per second is the unit. Okay. Okay. So I hope it's clear. Wherever you have any doubts, you can ask me. Okay. Okay, now always I talked about say kilometer distance or meter distance we talked about. So you can see that there are different range of units, right? Large units, small units. So we will start now look at a table. In this table, you'll find that there are these kinds of units given. So it starts from giga and it ends at nano. Do you have any idea which is the largest and which is the smallest here?
No.
Okay. Have you heard about nanoseconds? That
Yeah.
something is completed in nanoseconds
Yeah.
time? Have you heard about it?
Yeah.
Nano means a very small one. Okay. So here the minimum is the nano and the maximum is the giga. Giga means it's the maximum one. Okay. So here are different kilo. Kilo you must have heard. Kilogram,
Yeah.
kilometer, right? Then centimeter, millimeter, all these things you have heard, right?
Yeah.
So these are, I think, new to you. Giga, mega, then micro, nano. Micro is also very small and nano is smaller than that also. Okay. So they are defined as GW. So watt, here actually we are using the unit watt. Watt is the unit of power which you will study later in the chapter. Okay. So gigawatt means it's a very huge power and nanometer here they have used. So nano is denoted by the small n and it means a very small distance. Okay. So these are just examples I wanted you to know. So this table you'll find it in your book. It's there. Okay. Do you like maths?
No.
No? Okay, fine. No problem. So you see here, have you studied these things? Can you tell me that powers,
Yeah.
right? So thousands we can use right in this way also. 10 to the power of 3. That means you'll count the zeros and make it into the power. Isn't it? So 100 is 10 square. Then 0.1, that means it's actually 1 divided by 10. So the power comes to minus. So when we are describing the units, like giga, you notice it's 10 to the power of 9. That means 9 zeros are present there. Okay. So we can make use of this table. So we can see that my purpose to show this table is that there are different ranges of units from large to small. Okay. Now we come to a thing called scientific notation. What is a scientific notation? That means sometimes, say, if I say the population of a country, it's a huge number, right? So when we say, for example, population of Iceland is 320000, right? And the population can be more also. So suppose 10, 12 zeros can be added. So there is a chance of making mistakes that how many zeros you'll add. So that's why it's written in this form that 3.2 into 10 to the power of 5. Okay, so that means how many zeros are there, you will make it into the power. And if you write it in this form, it is said to be a scientific notation. That means it is making more easier to understand for us. Clear?
Yeah.
Okay. Okay, now here we will do a short numerical. Okay. Just give me one moment, okay? I'll share the screen. Okay, can you see this question number 4?
Yeah.
Just read the question number 4.
This equation is used to work out the area of a rectangle. Area equals length times width. If a rectangle measure 3 meters by 2 meters, calculate the area and include the units in the calculations.
So will you be able to do this?
Yeah.
Okay, let's try. So here the length and the width is given to us. So how can you find the area?
Doing the length times width.
Yes, so how will you say that it's the area will be equals to 3 meter into 2 meter? What is the answer for this?
6 meters.
6. And what is the unit? Any idea of the area?
Meters.
Meter?
Meters squared. I forgot.
Meter square. Very good. Okay. So you see here, this is also, so that means what did we get? That area is also a physical quantity, right? We could measure that. So it has a unit, sorry, it has a number as well as a unit. So units are different for different physical quantities. So for giving this idea only, I just wanted to do this numerical. I hope it's clear.
Yeah.
Okay, now we'll go back to the slides again. Okay, now here in physics, a very common units are used as SI units. So what is SI unit? It has certain definitions for each physical quantity. For example, the kilogram is the unit for mass in SI units. So we know that mass have different units, say gram, milligram. So in this SI unit, we use the kilogram. Then for seconds, for time, we use seconds. For length, we use meters. For electric current, we use amperes. And for temperature, we use Kelvin. Okay. So these are certain units which was defined by certain scientists and they named it as SI units. So this is not anything to understand. This is just information to know. Okay. So we are going to use this in physics. In all the chapters, we are going to use these units. Okay. So you have to be familiar with this. Now first we start with mass. So what is a mass? Any idea? We can say that, yes, right?
Yeah, mass is like, it's not the same as weight, but it's like.
So you can say that it's a measure of the amount of substance in an object, right?
Yeah.
Okay. So what does mass depend on? Can you try?
It depends on the weight of the object and like how the gravity impacts it in light.
Yes, very good. That means that when the Earth's pull is acting on all objects. So if suppose you have a 5 kg weight, mass, and if you want to pick that up, and if you have a say 1 kg mass and you want to pick that up also, which one will you feel easier to pick up?
1 kg.
1 kg mass. So that means the heavier the object, the stronger is the gravitational pull, and it is difficult to separate that. Another thing which the mass depends on is, suppose I'll give you one example. Some object is moving. Suppose a ball is coming to you, okay, and you want to stop that ball. It's possible for you to stop that ball, right? Because it has a small mass. Now, with the same speed, a truck is coming to you. So will you be able to stop that?
No.
No, right? So that also depends on mass. That the heavier the object is, the greater is the resistance. So these two things, it's depending on. So we already know that mass SI unit is kg. Now in Paris, there is an office of weights and measures. And how did the scientists define 1 kg? Have you ever thought about it? That the scientists first, when they told that this is 1 kg. So how did they got to know that this is 1 kg? So there is a certain definition of 1 kg. That is actually this one. Can you see the picture? That
Yeah.
it's a platinum metal which is present at the Office of Weights and Measure in Paris. Okay, so that thing had a weight of 1 kg. Now its definition has changed. So previously this definition was used. Okay, so this is just the history, nothing else. You don't have to study that and all. This is just knowing the history. Okay, now there is a approximately, you can say that an idea. What is the weight of anything? So a car has a weight of 1 ton, or you can say it's 1000 kg. Okay, just to give idea. And you know that 1 kg, it will be say 1 kg of sugar or 1 kg of anything else it can be. So you can pick that up, obviously. But 1 ton, you cannot pick that. You cannot pick a car unless you are Hercules or something, right? Okay. So then 1 gram. 1 gram, you can say a bank note, currency that can be weighing 1 gram. Then 1 milligram would be the human hair. So if you measure the weight of each human hair, you'll find it as 1 gram. So this is just to get the idea that how much the weight can be, or sorry, this is actually mass. Okay. Got it?
Yeah.
Okay. Now time. Time, I think you know what it, I don't have to tell you what is time,
Yeah.
right? So time can be measured in seconds, in minutes, in hours, right? But in SI unit, the unit is seconds. Second also had a definition that it could be defined as 1 divided by 16 to 16 to 24. That means this much fraction of 1 day. 1 day has 24 hours. So if you divide that, 1 divided by 16 to 16 to 24, that would give you 1 second. Okay. But now what the problem is that 1 day, what is actually 1 day? 1 day means 1 rotation is complete of the earth, right? That can be said to be 1 day. But that rotation is different. It's not constant throughout the year. I hope you know that. So it changes a bit every day. So it is not constant. So that's why they thought about a different definition, which is frequency of oscillation which occur in a nucleus of a cesium atom. Okay, this you might find it difficult to understand. So for now, just know it. Don't have to understand in details. Fine? Okay, so this is just a definition, just for the interest that how did the second idea came to us. Okay, now have you seen a pendulum clock?
No.
Hmm? Have you seen a pendulum clock before?
Yeah, in the movies.
So it looks like this. So have you seen that this thing, the downward portion, it oscillates to and fro?
Yeah.
This thing, it goes like this and like this.
Yeah.
So previously they used this to measure time, that once 1 second, 2 second, 3 second, 4 second, like that. Okay. So previously I'm talking about, but now they use a different kind of method, which is vibration made by tiny quartz crystal. Actually, in your house, you'll find that in clocks, the word quartz is written. Have you ever noticed that?
Yeah.
Yes, so that means they have quartz crystal in that, and if you count the vibration of that, each vibration is 1 second. Okay, so you don't have to understand again in details what is quartz crystal and what is vibration. So later you will study. Just know that this was the history of time or history of what is second. Okay. So here second also we can divide further in millisecond, microsecond and nanosecond. Suppose when have you noticed that in a race like running race, sometimes the winner is at say 6 milliseconds greater than the second one. So they are all running, right? So one is completing 6 millisecond earlier than the other, and he or she takes the first position. So here, there, the 1 second is also large. You can divide that into smaller divisions as well. Milliseconds, microseconds, nanoseconds. So these are very small. You can actually, you cannot imagine actually now. What is a nanosecond? 1 second only we can say just one ticking means 1 second. So 1 nanosecond you will not be able to imagine. But it's a very, very small unit. Okay. Okay, now next we come to length. Length we have already talked about. Can you tell me what is the SI unit of length? We just talked about that.
Meters.
Meters, right. Very good. So the SI unit is meters. So now what is 1 meter? Again, there is a definition of 1 meter. We know that the light travels at a definite speed. So we can say that 1 meter will be a distance traveled by light in 1 divided by this much second. This is just a definition, okay? Because we have to get something constant which doesn't change. Then only we will define that. A standard definition. Previously, there was again in the Office of Weights and Measures in Paris, there was a standard definition of 1 meter. Actually, there is one metal bar present there, and that was defined as 1 meter previously. But what happens is it is a metal. So during summer and winter, there can be small or little expansion or contraction in that length. So it will differ. That's why that is not a constant throughout. That's why they had to change and make it this 1 divided by this much second distance will be traveled by light. So that is a more standard definition. Again, just to get idea, we can say 1 kilometer is equals to, you can say this football pitch. Do you like watching football?
No.
No? Okay, you have seen, right? Football pitch. Okay. So you'll find that this is a 1 kilometer distance. Now 1 meter also, you'll have the idea that 1 meter, you get a ruler of 1 meter. Okay. Then 1 centimeter is a very small length. If you have a ruler with you, you can see that this 1 centimeter is one very small unit. Then 1 millimeter is smaller than that, micrometer. is the dimension of bacteria, which you cannot see with your own eyes, right? You need a microscope to see that. Then 1 nanometer is smaller than that. So this is just to get the idea of what it is. This table also you'll find it in your book. Okay, now we come to measuring of length. So till now we have talked about time, we have talked about mass, we have talked about length. Now how do we measure length? What are the instruments for measuring length? Okay, we'll see to that. One of them I just showed you is a rule, which can measure from few millimeters to meters. Okay. Next one is a calipers. Now what is a calipers? Calipers actually looks like this. Do you use this in a geometry box?
Like a compass?
Yes, like a compass. So what happens is that when it's a very small length and you cannot measure with a ruler, so what you can do is that place the caliper and then measure that distance with a ruler. Okay, that makes it easier to measure. Then another one is tape. You must have seen this kind of tape.
Yeah.
Right? So actually the rule has a limit. It can measure only up to 1 meter. If you want to measure a distance more than that, then you use a tape, measuring tape. Now to measure small lengths, we use these instruments, a micrometer and a vernier calipers. Okay, these things are there in the extended level. Are you studying the core level or extended level?
Extended level.
You are studying extended level?
Yeah.
Okay, fine. So in the extended level, you have this micrometer and vernier calipers. So right now, I'm not going into detail. So next, if you study, then I will show you. These are actually short videos. It will take time. So I'm not showing that. It looks like this. This is an instrument to measure very small distances, which you cannot measure by a scale even. Will you be able to measure the width of our hair by a scale or a measuring tape or a calipers?
The caliper.
By a calipers, will you be able to measure?
I don't know.
No. You will need some other instruments. Okay, we'll study that later, not now. Now measuring time. So to measure time, you must, I think you know what is a stop clock or a stopwatch.
Yeah.
Right? So stop clock actually looks like this when you have to measure some short interval of time. Okay. And stopwatch looks like this. Now stopwatch can be analog or digital. Which one have you seen?
I've seen the digital one.
Digital one, right? Okay, so these are actually measured during race, track race, or some swimming race or anything. Like to measure time, it is used mainly, interval of time. Now to measure a very short interval of time, it is more likely to make a mistake, right? Suppose if you're asked to measure 2 seconds, when you press the start button and when you press the stop button, it's very actually difficult to maintain the time. So to overcome that problem, what is used is that, for example, I'll show you a pendulum oscillates like this. Okay, so suppose one oscillation time you are asked to find. So how will you find when you start the stopwatch and when you end the stopwatch? The distance between them is suppose 2 seconds. So it is very difficult to just start and just stop. So that's why what they do is that measure for 25 oscillations and then divide that time divided by 25. Then you will get for each oscillation. Now what is oscillation? Or one swing you can say. Okay, I'll show you this. You see that when it is moving like this, so when from this position, it's going here and then coming back. So one oscillation is suppose How to measure that we are doing. So for 25 swings, if it is 55 seconds, for one swing, it will be 2.2 seconds if you calculate. Okay, so this is just one example that how to avoid that mistake, that when to start the stopwatch and when to stop the stopwatch. Okay, another method can be this. There are certain areas where automatic timing is possible. Suppose you want to measure that you are dropping one object from a height, from a very short height, and suppose and the time measurement is say 30 seconds, or not 30 seconds, also say 2 seconds. So 2 seconds, it's difficult to measure that when it's going to fall and when it's ending. So that's why there is a system like this. Somewhere you will find that there is a light sensor here and here. So when it is falling, suppose a ball is falling from a height. So when it is crossing this part area, there it is recording that it is starting, and it goes down, and when then it crosses this light, it ends. So it is automatically measured by this device. That's a device or an instrument which will automatically record how much time did it take. Okay, so these are some methods to rectify that. Okay, so this much we have for today.
Oh,
Okay, so any doubts from there?
no.
No? So did you like it?
Yeah.
Okay. Or do you like physics or no?
I don't like science, but I'm not good at it, so I need tuitions for it.
Okay, see, science is actually very interesting if you try to understand, right?
It depends on what we're learning. Like certain topics interest me more than the other.
Yes. Actually, see, in physics, I can tell you, because I am a physics teacher, that I also was there in school like you, and certain subjects I also did not like. But actually, in physics, what happens that you get to see the things around you, like when you are measuring time, when you are measuring length, all these things you are getting to see. Everything, when you look around you, everything measurable quantities. You can find it in your house also. If I tell you that in your room where you are sitting, find out the measurable quantities around you. So if you like it, it will be interesting. Anyway, so okay, so have a good day. So I'm ending the class
Okay.
now. Okay.
Bye.
Thank you. Bye.
Have a good day too.
Have a good day.